Weird, not, no, arithmetic-wise, it's not hard. It's a little odd because you never had it. You know, if you think back when you were in elementary, and a lot of that you won't even remember, but you know, the first time you saw percents, first time you saw fractions, you know, they were different, but you got used to them and you were fine. So it's kind of in that category. I'll show you where it comes from. Today is the 7th, and I only gave you 10 of them. Did I put the right lesson number on that? Was it 29? Is that what I put? Yeah. Now, where the concept of complex numbers comes from is not, at least, and I always say I'm going to look it up, but I always forget to go back and look it up. It's, I think I want to say maybe the 1600s. It may even go back to the 1400s, something like that. But mathematicians ran into cases of doing quadratic equations, but when we say they all have two answers, they were running into problems where we had, you know, now all the ones that we had in 27 and 28 had real answers, even though some of them were irrational. And I'm going to refresh your memory on that idea that this is a rational number, these are irrational numbers right here. But then they ran into numbers with square roots of negatives in them. And we've always just said no real solutions. And if you type the square root of a negative number into your calculator, the default mode will say no real solution. And it specifically says no, it didn't say no solution, but it says no real solution. And we'll see where that comes from. Now let me show you where complex numbers kind of start with the idea. If I have the square root of 6 times the square root of 6, what is that equal to? It's equal to the square root of 36, which is 6. I think we all agree with that. Now, is that true with variables? Square root of x times square root of x, is that going to be just x? I think we agree with that. Square root of x squared is x. So now take the square root of -1 times the square root of -1. And if you follow the pattern, the answer should be -1. But here's the problem. We've never defined, at least we haven't, and you've not seen the idea of what is a square root of a negative number. And again, your calculator tells you it's not a real number. So let me get a piece of scratch paper and let me show you kind of what I'm talking about. If you, now these little people printed a whole lot of these assignments and then they didn't use them all, so I'm going to have to fuss at my little children. I don't mind them printing, but I don't need them not using them all. Okay, let me give you this concept. If you remember from middle school, elementary school, somewhere along the line, I always say to you, let's put all the real numbers in the room. Now, when you start learning numbers, I'm just going to put real on that. When you start learning numbers, you learn just your counting numbers. And usually you just learn like 1 to 10, but you learn they do go on forever. And in terms of, they are real numbers. And rationals on this side. And you work with rationals a long, long time. Y'all need to get settled. Some of you are writing, I don't know what you're doing, but you need to get with me. If you're writing headings, just stop, get with me. Because like I said, this is new. You've not done this before. It's not hard. It's just a little weird. It's just something new. And you can split it. And most of your elementary career, you deal with rational numbers. Rational numbers are numbers that if you write them as decimals, they end or repeat. Like 1/2 is 0.5. 1/2 is rational. All your counting numbers, 8, all your negative numbers are rational. You know, most every number you name is going to be rational. And when you get over to, and the decimals end, like 0.4, or they can repeat, like 0.3 with a bar over it. That's 1/3. Those are all rational. Irrational came in, the first time you probably saw irrational was pi. And pi is a number that never ends, never repeats. You know, it just keeps on going, so we usually just have to use it rounded. And then what fell into that category is when you started seeing, and I don't know when, maybe Algebra 1, Algebra 2, square root of 7, square root of 19, those non-perfect squares. You know, now square root of 4 is going to be over here because that's 2. Square root of 36 is going to be over here. But those are the irrational ones. But here's the deal. Complex numbers are not a category over here. They're actually a big box that surrounds. So all real numbers are complex numbers, but not all complex numbers are real numbers. See? Because there's real in here, and there's going to be complex numbers in here, and then all the real numbers are complex. So what you just have to visualize. I always say to students, take the room, put all the real numbers in it, split it down the middle, put rational on one side, irrational on the other. You know, that's where we talk about that box. But now there's a box that's outside of us that we're in, but it's a bigger box. There's more numbers in it. So it's just telling you that it's just kind of expanding it. Now, where that comes from is based on this idea right here. So mathematicians, now why they picked the letter they picked, I don't know why, but they defined a new number as I. And they let I be equal to the square root of -1. Write that on your paper. That is totally new to you. Everything I'm writing, you better be writing. I is equal to the square root of -1. Now, I, as long as it's by itself, just i's, work like variables, but you have to recognize, and that's where it's a little weird, because it looks like a variable, but it's not a variable. It's a number. Let me give you an example. If I say what's x to the 4th, well, all you can do with it is x times x times x times x. I mean, that's all you know, depending on what x is. But if I say what's 2 to the 4th, then you go 2 times 2 times 2 times 2 is 16. Well, i's going to be the same way. You can take I and raise it to a power and get an answer because it's not a variable. And very rarely, I've seen a few books, I is a variable, a variable that looks like a, let me say it backwards, a number that looks like a variable, and there's another one, E. You don't usually get into that until a college algebra class. But I and E are numbers that we usually don't use them as variables. We tend to, sometimes elementary books do, but we tend to stay away from that because they do have other recognition with them. Let me just make sure you can see that. Well, that's going to be the important, but probably the most important one is if you take both of those, you know, if I have, I think that's what we were doing over here. Weren't we squaring? We were actually going the other way. We took the square root. Well, if I take the statement, I is equal to the square root of -1, write that on your paper, and let's square both sides. So let's square this, and let's square that. You can, I tend to put it in parentheses, but you don't have to. Well, so I've got I squared is equal to, well, if it's really what you did right here. The square means the square root of -1 times the square root of -1 is -1. And I'm going to tell you, of both of those statements that we've made, this one and this one, I'm going to tell you this one is probably going to be more important to you in the scheme of things, of where we're solving quadratic equations. Because we're fixing to get into problems that don't factor. See, as quadratics, this one would have factored, this one wouldn't, because it had irrational answers. It had a radical. And so what you have to recognize is that i's are radicals. They're square roots. They're just square roots of negative numbers. So as we go through them, that's what you want to recognize. But i's are going to act like variables as long as you're not raising it to a power. Let's try some. Let's add and subtract them. I dare say if I'd have given you this problem first, I think you would have, I don't think, if I even talked about it, I think you would have said, oh, i's a variable and I'm going to work it. Let's do 5 plus 2i. And let's add, now I will tell you that on your classwork, sometimes they put them in parentheses and sometimes they don't. Oh, something I didn't do. We better stop and do that right now. We can put it up here. A complex number oh, and I need to tell you something else too, is written as A plus, and I'm going to put the B as cursive. You can write it like you want to. It should come back. If it goes blue, it usually comes back. Plus BI. You put the This part is your A, and this part is your B. Now let's talk about it. A is going to be your real part. That's the numbers like we've always known. That's the numbers that are in the real number box. They can be square roots. Very rarely they are. Most of the time they're going to be like a 1/2 or a 2/3 or something like that. It may be an 8. And then this part is called. Now here's where, and I think they call them imaginary because of the I. Teachers don't like that word, and I'll tell you why. Because a lot of times teachers say, we're going to talk about imaginary numbers, and they say, well, they involve I. Well, I don't like to call them imaginary, because things that are imaginary, they aren't, it's not real. Imaginary numbers are not real, but they're, I don't know, I usually can tell you how far we're behind, because normally this lesson's taught around Halloween. Because I will say, ghosts and goblins are imaginary. You know, you have these imaginary things around Halloween and all that kind of stuff. And I'll say, I is not an imaginary thing. It's not something that's just a figment of your imagination and it doesn't exist. It does exist. It is a number. It's a number just like 2 is, just like 8 is. It's just a new number that you've never seen before. And it's equal to the square root of -1. They had to define it like that. This is the most common place you're going to see it, but the last 4 problems of your classwork, and we're going to do a couple of those here in just a second, are going to be more like what you will see when we get into more quadratic equations, harder ones, and the calculator's fixing to come back into it, because your calculator does a lot of this for you when you set it into a certain mode. Like I said, if you leave your calculator like it came from the factory, if you type in the square root of -1, it's going to say no real number. And it isn't. It's not a real number. It's an imaginary, or teachers prefer complex, as we say that. Now, I think you can do this one without even knowing what imaginary numbers are, or complex numbers, because what are you going to do when you add these? And again, some of your problems don't have parentheses in them. That's still okay. You're going to put your like terms together. And so in this case, 5 plus 8 would be 13, and then 2i minus 7i would be -5i. You treat it like a variable. As long as you're not multiplying, it's going to work just like a variable. It's very easy. Now, I was going to show you that notation, that if I have in here numbers that have like 6 plus 2i is going to be in this category. It's not going to be up here. So how can all these numbers be considered complex? So take the number 8. 8 can be written as a complex number because all I have to do is add a 0i to it. See, it has a real part. That's the real part. And then the 0i is the complex part. So that's why complex numbers are not just another room over here. They're a big room that include us. It's a complex number, but it doesn't have an imaginary part. I guess the easiest. We don't run into these a lot. You may, but I just wanted you to recognize that. I do emphasize the A plus BI form if we are doing them like we're doing right here. Is -5i plus 13 wrong? No, but it's not the format. And there are some college professors. I don't think Miss Newberry gets too bent out of shape over it, but I have had teachers where they're very emphatic. Put the real part, put the imaginary part second. So make sure your I is the second part. Number 2, let's